TTL Computer II. Today, we're going to take a look at our next two devices that we're adding to our digital simulation. And those are going to be a monitor and a keyboard. And it should be obvious why we're adding those next two things, because we need those to have to make a terminal up, and so we can interact with the keyboard and the screen like we want to with a computer. Okay, so I'm going to just briefly look at these so we can see it. We already had our hex display, and all of our devices again are memory mapped, and our hex display was memory mapped at address 2001. So likewise, we have our monitor is going to be addressed at address 2002, and our keyboard is going to be memory mapped at address 2004. And we can just take a brief look at these circuits. And, this is very similar to what we saw with our hex display, right? We have our address bus coming in. We have a little bit of logic here that decodes address for 2002. And then in this case, this is a write-only device. The terminal is a write-only device. We detect the write signal, and we use that as a clock into our terminal, and that will clock in whatever on the data bus. Okay, so that is for our terminal. And we can take a look at our keyboard, and this is going to be, again, a very similar circuit. So we have our address bus, we have our decode logic for 2004. And this device is actually going to be a read and a write device, because what we're going to do is on the read signal, we read from the keyboard, and when we do a write to the keyboard, it actually is going to flush out the character, the oldest character from the keyboard buffer. So this way it empties our buffer. So the process would be, a read a character, and after we've read the character from the keyboard, we'll do just a dummy write back that will clear that from the buffer. And then we also see here that we buffer with the data coming out of the keyboard, all right, onto the data bus when we do the read. Okay, so that's our two devices that we have memory mapped, our monitor and our keyboard. All right, so I think we're ready to start this up and see what we get. All right, so we're going to start our simulation, and we can see here that this little keyboard object popped up, and we're going to do the reset now. And here's our monitor, and you can see that I've already started the code for our TTL2 monitor program. Right, we have our little welcome message here, and we can do enter. Right, we just have our monitor prompt. We can do a question mark, and it will show us the commands that we have implemented so far in our monitor. And this is a good point to just want to have a shout out for a fellow YouTuber, Phil G2864, and I've had his channel added to my feature channels list on my homepage. So please visit Phil. He's got some interesting videos out there. He was kind enough to contribute his monitor code for his Z80 computer for me to include in my Z80 computer some time ago. And I've adapted that code from Phil for our TTL2 monitor. And we can see that is partly up and operational here. So what I'm going to do here is I'm going to stop our simulation. We're just running at 5,000 hertz right here. And that was a good speed to just show the welcome message come up the first time, but that's a little slow for once we're going to start using the monitor. So I'm going to change our clock speed up to 50,000 hertz. and restart our simulation. And we do our reset. You see that the screen just pops up almost instantly. So we don't is a better effect at the 5K hertz for the first monitor launch. Okay, so our monitor is going there. So we can do dump, and we can specify address 0, and we're just dumping out, right, the beginning of our ROM. Let me make this a little larger. We can just hit enter to go, to the next chunk of memory, right? And period to end. So this works. The monitor is working the same way that my TTL computer monitor worked, right? So we have also, that was the dump command. We have the modify command, and we'll modify also address 0, whatever, right? We could change the code, but we're trying to change the code on the ROM, and that's not doing anything because it's a ROM. Let's look at that again, so we can see that we didn't change any of the code, any of the values, any of the memory. It's back to whatever was in the ROM. Okay, and then we can also, so we looked at the dump, we can do our go-to command and just specify the address. So we can go to address 0, and that just goes right back to the beginning of the monitor. But let's do something that's a little bit more interesting. Let's do modify, and let's do address 9000 this time. Okay, so we're about to update some memory. So if we remember back from our earlier video, last video, 39 is our code for jump, unconditional jump. And so we just entered that in there. And so we're going to leave 0, 0. All right, so let's just dump this. Right, so we have entered a jump command. We see that we have jump, and then followed by two bytes for a long jump. So this is just going to be a jump back to address 0. And so that's going to be the same as doing this, right? That's jumping to 0. But now we're going to go to address 9000, which is a long jump back to address 0. And we can see that that works. So we've kind of, done some basic monitor work here. And I also implemented the Intel the hex loader, which again, Phil implemented that. So it's just his updated code. But the Intel hex loader is been entered, and I tested it with with a hex file that I just typed in myself, because unfortunately the keyboard and the monitor don't have a paste functionality. So I'm going to have to do something more elaborate, where I'm going to have to do a more substantial program that I want to try and load with the hex loader. And I'm going to have to load that into ROM, and then read it out of the ROM as if it was coming from the keyboard, which is what it would be doing once we get the real terminal up and going and we're using our serial, IO. It will be coming from as if it's typed in from the terminal. So I'm going to want to do that as a next step, but I'm not going to do that right now. So again, I want to just look at the speed of the speed of the system. Now we're running at 50,000 hertz here, and our initial clock in our physical implementation is going to be a 4 megahertz clock. And then since we have a 4-phase clock, it's going to divide that down by 4. So our effective system clock is going to be 1 megahertz. So, that's going to be running, 20 times faster than what we're seeing here. So it should be a pretty responsive system once we get up and going live. Okay. So I think that's it. That's all we're going to look at today. So you can see that we really have the start of an effective system here. We looked at our two new devices, the monitor and the keyboard. We saw how they're memory mapped in, mostly very similar to how we did the hex display. And again, this kind of the monitor and the keyboard are mimicking our serial card that we're going to have to put together with our UARTs, right? This is effectively the send and receive UARTs are going to be substantially the same as the monitor and the keyboard devices here. So, but we won't realize that probably until we get to our physical design. I'm not sure if we're going to be able to simulate that in our simulator or not, but we'll see if that makes any sense to do. But I am leaning towards using my PIC microcontroller solution for the UARTs, but that's not finalized, but I'm thinking I'm going to do that since it's a bit of a known entity for me. But hey, that's it. That's our monitor. And I think this really effectively ends our digital design phase, our logical design phase for TTL Computer II. After this, we're really going to be switching to the physical design phase, which I've really already started. So in our next video, we will kick off our physical design phase, and I'll show you some of the changes that I've made to our logical design and starting to bring it closer to what the physical design, closer to the inputs that we need for our physical design in our circuit design software. So until next time, that's it. Thanks for watching.